University of Genoa is the leading partner of the project PROMPT, which is focused on the preparedness against contaminant dispersion in sea and waters in harbor environments. The project continues works and activities developed in another project funded by the DG ECO program from the European Union. The previous project was called Be Ready. And in this project, basically, we extended the capabilities and the analysis to new applications like oil spill detection from satellite images and container detection from, again, satellite images. On the other side, we are developing hazard and risk modeling for contaminant dispersion for the harbor of Genoa that completes the harbor of Tripoli, of Aqaba and of La Spezia already analyzed in the Be Ready project. And we add the new ingredients to the dispersion analysis of contaminants, take into account the atmospheric dispersion of the volatile part of the hazardous material and oil spill that we can find in harbor waters and that can separate from the liquid phase and disperse in the atmosphere. University of Genoa is developing the numerical models, and the results of the numerical models of the dispersion of the contaminants we will put together with the decision support system developed by IAC Cantabria that will give a tool to the managing authorities of the port area in order to prevent ocean contamination and ocean pollution. This tool works on the basis of offline forecast, which is a technique that has been developed by our research group. We run offline a set of climatic conditions that has been selected on a long database of history of metocean condition, information about wind, ocean currents, waves. So once you have the forecast for the next days, we develop an algorithm which compares the forecast with those scenarios and produce a rank of the scenario. What does it mean? We can identify which scenario is the closest to the future forecast. And so the managing authority can have an insight, if it happens an accident, of the dynamic of the dispersion in the next future. So can organize activities and mitigation action to take place, like calling boats to clean and to segregate the spill, or giving hazard and alert messages to the navigation, to ships and to operators in the port area. And finally, we will add to the system as well the automatic detection of containers and oil spill in the proximity of the harbors of the project. So once an accident will occur, there will be the possibility to track real-time the pollution, either with numerical models and forecast systems or with remote sensing like satellite images and algorithm dedicated to the tracking of these kind of contaminants or objects which are really dangerous for navigation and eventually for marine pollution as well, because sometimes in container you can find as well hazardous and polluting materials. We use these objects that are called drifters because we just put them in the water, we launch them in the water from a boat, and then they have a tracking device inside, and so they give their position in time for a long time, like a few days. So then we collect the information and we can compare the information coming from the drifters with the simulation that we did. And so we can validate our model, so we can give a rate of reliability of our model.
Was this a startup in Luxembourg? And it is based around a platform, a cloud platform that helps remote sensing experts turn their algorithms into applications in the cloud that can then be used to address real-world problems. In the context of the PROMPT project, we have two tasks. The first one is mapping oil spills. The second one is detecting floating containers. By mapping and by detecting, I mean developing an algorithm and automating it using WASD so that they can be run as services. Let's discuss how to map oil spills. For this problem, we are using an approach developed by our partners, the Luxembourg Institute of Science and Technology, which exploits Sentinel-1 data. So the instrument sends a signal towards the surface of the sea, and the sea tends to be slightly rough. But if there is an oil spill, then that area becomes smoother and the signal from the satellite gets reflected away. So no signal returns to the satellite. What that means is that looking at these satellite radar images, the oil spills are black, very dark. So they can be more easily segmented. So that's the general idea, the general concept that we are using here. Let's discuss the problem of detecting containers. First of all, it's a cost. And it's not easy to retrieve them, but if they sunk, so that's value lost. Second, it's an environmental problem because they often contain polluting substances. Third, it's a hazard for navigation. In fact, these containers can float, and they do float at least for a while until they get filled with water. And if they're not detected in time, an accident can occur, collision can occur, which can be fatal, maybe especially for smaller ships, but not only. So the problem is relevant. Unfortunately, it's not possible to detect them using publicly available imagery. Some of them might appear like 1 pixel in an image. So we are planning to do an experiment in the port of Tripoli in Lebanon. Our partners are going to float a couple of containers, and we are going to task the acquisition of a very high resolution commercial imagery over the period of the experiment in order to build a data set on top of which we can then work. And we have some ideas on how to detect these containers. Basically, we are going to try a couple of big families of approach. The first approach will be traditional statistical methods. We're going to exploit the fact that the containers have a different color from the sea. We have two containers in this experiment. One is red, the other one is blue. So we expect this approach to work rather well. With the red container, we are not sure about the blue one, but we chose blue exactly to challenge these techniques. The second family is the AI-based family, and these techniques keep evolving very quickly, I would say on a daily basis, and we now have general purpose models that can be used in detection and segmentation tasks such as this one. So the first approach, the first attempt would be to test them as they are out of the box, and then we may be willing, if necessary, to do some fine-tuning and see if we can improve the performance of these models.
In the PROMPT project, IH Cantabria is involved in different tasks. The first one is implementation of the numerical model for oil and chemical spills in the marine environment and the development of the risk assessment methodology. The risk methodology is based on the combination of the hazard and vulnerability and is estimated taking into account different indexes for example, economic, ecological or human issues. The second task is the development of the decision support system for PROMPT. All the information generated with the numerical models and the risk assessment is integrated in the DSS. The DSS is made up of two different modules. The first one, the operational forecast module, to simulate, in case of an accident, the forecast of the transport trajectory and dispersion of the oil or the chemical spill. The second module is the risk assessment module, which provides a probability, vulnerability, and risk maps for the marine and the atmospheric pollution. This information is very useful for improving planning and preparedness. Finally, IH Cantabria is also involved in the training on the use of the tools and the risk assessment maps of training the framework of the project.
Our main duty in this project as Port of Tripoli is to track lost containers. So we will throw 2 containers. The first is blue, the second is red. These 2 containers are 20 feet containers. So the small one, not the 40 feet or 45 feet containers. In Port of Tripoli, we have main breakwater and secondary breakwater. The distance between these 2 breakwater is 237 meters, which is the navigation channels. So between these 2 breakwater, vessels can enter through this navigation channel. So our experiment will take place close to the secondary breakwater. This is for the first container. The same will be done for the second container. It will be more than 100 meters away from the first. All the steps of the experiment were done successfully. Cristiano couldn't get high resolution for the images, so he aimed to get more high resolution, but he couldn't at the end, unfortunately.
So in Jordan, as a pilot's area in Gulf Aqaba, we apply the very, very strong, actually, a model that can really give you a prediction how the spill will flow with the currents. So what's our role in this PROMPT, the second one that starting years ago and still running actually, is to enhance this software by having more boundary conditions that measured really, or having real measurements, will provide the model for more accuracy and good resolution to estimate or to predict the oil spill around the Gulf Aqaba, for example. We know that the oil spills mostly remains for maybe hours or day, and then it's convert to another chemical compounds. So the idea for prevent or to trying to facing or to solve any oil spills is in the first few hours. In the first hours, after that, it will be difficult to, it's a irreversible process. So we need to have action. There is no time to wait and think too much. And we know that the most difficult is to predict the water, how it moves in the ocean. It's a fluid, and the fluid has many characteristics. It's incompressible, and it's really randomly sometimes moved, but of course based on the external or driven forces. So we're trying to controlling all these things, the driven forces, that the wind and the current itself that depend in different factors. But since we have current meter for as long as possible information, so we can have an idea how this water current is moved seasonally. Meteorological conditions is easier to predict, and we can, of course, combine these all external forces to build up this model with the initial and boundary conditions.
What does happen when something is released on the water? Sure, you have a marine component, but also when you talk about oil, you have an atmospheric part which has to be studied and considered. And that's our role. We talked about the atmospheric impact that you have when some accident happens in the airborne area. So something is emitted in the air and this dispersed. And when the harbor is close to the urban area, maybe population is exposed to some toxic pollutant. So what does it happen when an accident becomes? The decisor can use the PROMPT tool and understand which is the best intervention to be adopted to mitigate the impact, both in the marine environment and the atmospheric environment.
RE is responsible for communication, dissemination, and capitalization plan. So we make sure that the project activities, results, and impact are being disseminated to the right stakeholder. So basically, we have three fundamental activities that we are responsible as far as work package 2 is concerned. They are the project establishing or developing the project identity and enhancing visibility, which is under that activities we develop the logo of the project, but also we provided some kind of promotional materials. And also under that activity, we created what we call some social media profile like Facebook, like Instagram. But most importantly, we leverage also the side of the UCPM, which is the Union Civil Protection Network platform, which was dedicated by the project, anyway, by the EU, basically, to make sure that all the project result activities are being disseminated there. So among the activities that we are that under our responsibility to facilitate is the training and evaluation, because by the end of the day, when we develop the concept and the innovative added value to the prompt project, which is basically a software, which is DSS, decision supporting system, we have to make sure that we train the end users to be familiar with this concept.
Each one of these projects is a ring in a long chain. If there is any kind of accident, these kind of projects are very, very important to get more experience, to be ready, to have high response to the accident, and especially the environmental ones.